Al Gore may not have invented the internet, but you can thank the United States military for it. That's right, you can thank the US government for Tinder. The US government helped create the internet. Here's how. 1957, 10 years into the Cold War between the United States and the Soviet Union. The battleground was technological superiority, and Americans had the upper hand. That is, until the Soviets launched the Sputnik 1 satellite. In response, the military created the Advanced Research Projects Agency, or ARPA, to develop new military technology and put America back on top. The US military was worried a nuclear first strike from the Soviets might wipe out their communication system, leaving the US unable to respond. So they set out to create a protected emergency system. They established computer research centers at leading scientific universities. But computer scientists needed to connect these geographically separate systems so that they could share research and information. In 1966, the ARPANET program, headed by Larry Roberts, began work. On October 29, 1969, the first message was sent across the ARPANET from UCLA to Stanford. UCLA student Charlie Klein started typing login and typed LO before the system crashed. In 1970, the Network Control Program was released. The network expanded from 10 smaller computer networks, or nodes, in December 1970 to 15 nodes 4 months later. By 1972, there were 19 nodes linked together on ARPANET, but it still wasn't used all that much. Each host computer essentially spoke a different language, and most users only knew the language of their own host. ARPANET needed a way for the computers to talk to each other, so scientists began meeting to discuss both technical and philosophical aspects of the network, and formed the Network Working Group. In late 1971, the first user-to-user email was sent and mailing lists spread across the network. By 1973, email accounted for 75% of traffic on ARPANET. Meanwhile, other networks were being built around the world, but they had no way to talk to each other. So in 1974, Robert Kahn and Vince Cerf presented the Transmission Control Protocol/Internet Protocol, or TCP/IP, which acts kind of like a handshake that introduces distant computers to each other, and it makes today's internet possible. But the internet of 1974 still wasn't something just anyone could use, until Tim Berners-Lee created the World Wide Web in 1989. So, while Al Gore may have been the first politician to really support and promote awareness for the internet, its invention came long before, and it would not have been possible without the pioneering researchers and hackers who knew computer networks could do more than launch a counterstrike.
Hi students. Is everybody okay? Hope everybody fine. Today is our final lecture. We already arrived to the final topic for this subject. So, I hope you be able to give me all your concentration for this final topic. Before we start, let's recap to the previous topic. Previous class we have learned regarding multimedia authoring tools. Multimedia authoring tools provide a framework for you to perform an editing and organizing your multimedia elements. There are 3 types of authoring tool that you can use to edit and organize your multimedia elements. First is page or card-based tool, second is icon or object or event-driven based tool, and third is time-based tools. Then, the final information that we learned is regarding text and color compatibility between Macintosh and Windows computers or other operating systems. Okay. Now we go through the topic overview. In this topic we will learn about the internet and networking. How the network work. A brief explanation on the network connection. Moreover, short discussion on the www and the HTML. However, the discussion regarding the HTML code will be conducted during the lab session. And finally we will touch on the multimedia on the web. Next, is about today learning objectives. The first objective we will discuss on the origin of the internet. The second objective is to discuss on the networking and its structure. The third objective we will learn regarding a common protocols used in networking and internet. Then, the fourth objective is about bandwidth, The fifth and last objective we will discuss about the dynamic HTML and plugins for multimedia on the web browser. Nowadays Internet is very popular delivery method, communication method, and as a primary resources to the peoples around the world. All the good and bad things are on Internet. It is depend on how you utilize the Internet. The Internet actually started as a research network funded by the Advanced Research Project Agency, ARPA, of the U.S. Department of Defense. When the first node of the ARPANET was installed at the University of California, Los Angeles, UCLA, in September 1969. By the mid-1970s, the ARPANET, Internetwork, embraced more than 30 universities, military sites, and government contractors. And its user base expanded to include the larger computer science research community. By 1983, the network still consisted of merely several hundred computers on only a few local area network, LAN. In 1985, the National Science Foundation, NSF, aligned with ARPA to support a collaboration of supercomputing centers and computer science researchers across the ARPANET. The NSF also funded a program for improving the backbone of the ARPANET, by increasing its bandwidth from 56 kilobytes per second to T1 and then T3. And branching out with links to international sites in Europe and the Far East. In 1989, responsibility and management for the ARPANET was officially passed from military interests to the academically oriented NSF. And research organizations and universities became increasingly heavy users of this ever-growing Internet. Much of the Internet's polite etiquette and rules for behavior was established during this time. These early rules are being revised, of course, by newer generations' jargon and manners. In 1990s, more and more private companies and organizations linked up to the Internet. The Internet included connections to more 60 countries and more than 2 million host computers with more than 15 million users worldwide. Commercial and business use of the Internet was not permitted until 1992, but businesses have since become its driving force. By 2001 there were 109,574,429 domain hosts and 407.1 million users of the Internet, representing 6.71% of the world's population. By middle 2012, about 1 out of every 3 people around the world had access to the Internet, and more than 51 million domain names had been registered as .com. Let's we see the table present in the slide to summarize the usage of the Internet around the globe. Okay. Now we learn about Internet working. In its simplest form, a network is a cluster of computers, with one computer acting as a server to provide network services such as file transfer, email, and document printing to the client computers or users of that network. Using gateways and routers, a local area network, LAN, can be connected to other LANs to form a wide area network, WAN. These LANs and WANs can also connected to the Internet through a server that provides both the necessary software for the Internet and the physical data connection, usually use a high bandwidth telephone line, coaxial cable TV line, or wireless. Individual computers not permanently part of a network such as a home computer or a laptop can connect to one of these Internet servers and with proper identification and onboard client software obtain an IP address on the Internet. Okay. Let's we see the simple Internet working diagram on the slide. The orange circles is a LAN network, where there is several devices connected to the network hub or router. Then, every orange circle in a different building and location. Connection of every orange circle to a same server in a same location or district been recognized as a metropolitan area network, MAN, which is grouped in a blue circle. Several MANs in a different location connected to a single server in a same geographical area will be known as wide area network, WAN, which is grouped in the red circle. Then, communication of several WANs in different geographical areas and access to the unknown server's location we called as Internet. Okay. Next we will learn about Internet address and TCP/IP. So, what is Internet address, and what is TCP/IP? Is Internet address purpose similar to our physical address? Before that, we take a look to the figure. The figure shows the conceptual network layer standard used to send and retrieve the data through the Internet or Ethernet. We have two network layer which are TCP/IP network layer or OSI network layer. TCP/IP network layer consists of 4 layers, while OSI network layer was detail out all layers and consists of 7 layers. I do not plan to explain in detail about all these layers because we not in the network subject. We in multimedia subject. Hence, that enough you know the basic information regarding the layer. At the end of this video, I will share with you several YouTube link for you to have further information regarding the network layer. Alright. Now we want to learn about the Internet addresses. Before I explain the Internet address using the computer term and so on, I think it is better for me to explain the Internet address using layman word. So, you will have an idea what is Internet address, what is the purpose, and how it's work. Internet address is an address of the location that computer can access to a server or other computer to retrieve the data or file digitally. Every device that attached to the network will have their own unique address in order to send a request or to receive a response from the request. Furthermore, the address is not limited to the devices attached in a network. All data or files stored in the computer and shared in the network also had their own unique address. Hence, when you request to access to the shared data or files in the network, it is actually you send a request to the address of the data or files been stored in the network. As a feedback, the computer or server will respond to your request and send you a data or files that you want and display it on your device screen. This is how the Internet or network address work in brief. Now, I will explain the Internet address using the computer terms. It is start when the original ARPANET protocols for communicating among computers were remade into the current scheme of Transmission Control Protocol Internet Protocol, TCP/IP, in 1983. The Domain Name System, DNS, was developed to rationally assign names and addresses to computers linked to the Internet. Top-level domains, TDL, also called first-level domains, were established as categories to accommodate all users of the Internet. In late 1998, the Internet Corporation for Assigned Names and Numbers, ICANN, was set up to oversee the technical coordination of the domain name system, which allows Internet addresses to be found by easy-to-remember names instead of one of 4.3 billion individual IP numbers. In the early part of the 21st century, ICANN approved a few additional TLDs. As a particular domain name is built up from the top-level domain, it consists of different levels separated by period and was called as dot. Table shows several top-level domain exist. Moreover, the two-letter of US domain is based on the political boundaries. For example, .us, .ca and etc. Common TLDs as listed in the table are .com, .edu, .gov, .org. You must be able to memorize several TLDs with the intended purpose to answer the test question. Next, this figure shows you the clear picture where is top-level domain is located in the URL or Internet address. The Internet address will start with the protocol normal user will use HTTP or HTTPS, which the HTTP means Hypertext Transfer Protocol and HTTPS the S means Secure Site. Other than HTTP or HTTPS we also have other protocols such as FTP stand for File Transfer Protocol, SMTP stand for Simple Mail Transfer Protocol and much more. Then, after the protocol, the Internet address will follow with subdomain, domain name, and lastly is top-level domain. Other top-level domain, we also have second-level domain. Many second-level domains contain huge numbers of computers and user accounts representing local regional and even international branches, as well as various internal business and management functions. So, the Internet addressing scheme provides for subdomains that can contain even more subdomains. As shown in the figure, we have two URL, which the top figure only contain top-level domain and the bottom URL contain second-level domain. In addition, the URL stand for Uniform Resource Locator. Then, the URL that you type in the URL field on the web browser will be converted into an IP address. IP address is a 4 numbers separated by period as shown in the figure on the slide. The IP address is a 32-bit address that's shown in binary number. Some of IP addresses are assigned by the Internet authorities, and some may be dynamically assigned by Internet Service Provider, ISP, such as Telekom Malaysia when a computer logs on using a subscriber's account. IP address is a unique number for each device attached to the Internet or network. Next is TCP/IP. TCP/IP is stand for Transmission Control Protocol Internet Protocol. TCP/IP is a network standard, specifically a protocol that defines how data are routed from one end of a network to the other, ensuring the data arrives correctly. TCP/IP describes rules for dividing message or data into small packets and providing each packet with addresses, checking for and detecting errors, sequencing the packets, and regulating the flow of the data along the network. TCP/IP has been adopted as a network standard for Internet communications. Thus, all hosts on the Internet follow the rules defined in this standard. Internet communications also use other standards, such as the Ethernet standard, as data is routed to its destination. When a computer sends data over the Internet, the data is divided into packets. Each packet contains the data, as well as the destination, the sender, and the sequence information used to reassemble the data at the destination. Each packet travels along the fastest individual path to the destination's computer via communications devices that we called as routers. This technique of breaking a data into individual packets, sending the packets along the best route available, and then reassembling the data is called as packet switching. Now, we talk on connections. If your computer is connected to an existing network at your home, university, or public place, it is likely you are already connected to the Internet. Either using an Ethernet connection means wired or a wireless connection. You will need a broadband cable modem, digital subscriber line, DSL, modem, or other routing equipment to connect to the backbone of the Internet through an ISP. If in your house you use UniFi to connect to the Internet, means you already subscribe to the Telekom Malaysia Internet Service, where Telekom Malaysia is the Internet Service Provider, ISP. The connection for the UniFi is using the fiber optic cable. But if you use Streamux for Internet connection, you still use Telekom Malaysia as your ISP, but the connection is used the telephone line. Both UniFi and Streamux is a DSL connection. As stated in the slide, the ISP can offer one or more point of presence, POPs, to connect to the ISP server. However, to get the connection you need a point-to-point protocol, PPP, and TCP/IP software. The amount of data is expressed in terms of bits per second and is known as bandwidth. The greater the bandwidth, you will have less time to upload and download the data. But, the low bandwidth, you will face the bottleneck connection to upload and download the data. Therefore, to avoid the bottleneck connection, you can use the technique suggested on the slide. You can compress the file to reduce the file size. You can limit the users to download the data. If you want to deliver the multimedia file, you can design your multimedia elements efficiently and compact. Next, maybe you be able to design an alternative path for users to get your data in order to accommodate all users. Finally, you be able to implement streaming methods that allow data to be transferred and displayed incrementally as it comes in without waiting for the entire data file to arrive. Next, is the figure of the type of the connection exist in this world to connect to the internet and its bandwidth. Additional information: if you watch Netflix, you will need 0.5 megabyte per second as a require broadband connection speed. 1.5 megabyte per second as a recommended broadband connection speed, 3.0 megabyte per second as a recommended for DVD quality, 5.0 megabyte per second for high definition quality, 7.0 megabyte per second as recommended super high definition quality, and 12 megabyte per second as recommended for 3D high definition quality. Alright, before we take 5, let's we finish this subtopic. Each internet service is implemented on an internet server by dedicated software known as daemon. Daemon only exist on Unix/Linux systems. On other operating systems such as Windows, the services may run as regular applications or background processes. Daemon are agent programs that run in the background, waiting to act on requests from the outside. In the case of the Internet, daemons support protocols such as the HTTP for the www, the Post Office Protocol, POP, for email, or FTP for exchanging files. All this protocol you have probably noticed that the first few letters of a URL. Furthermore, if you work with multimedia on the Internet, you must work within the requirements of the appropriate protocol, using recognizable documents and formats. For example, a voice attachment to an email message must be identified by the post office daemon for what it is, and then be transmitted with the correct coding to the receiving computer. The receiver must have the proper software and hardware for decoding the information and playing it back. To identify the nature of the data transmitted and, by inference, the purpose of that data, the Internet uses a standard list of file name extensions called as media types. These were formerly known as multipurpose Internet mail extensions, MIME types. Most browsers allow you to define media types and map helper apps to the type for decoding and playing. Okay, let's have a break 5 minutes. Please come back after 5 minutes.
The evolution of the Internet has brought us to the brink of what's known as the Fourth Industrial Revolution, and it's going to fundamentally alter the way we live, work, and interact with one another. But how did we get here? Well, the first industrial revolution used water and steam power to mechanize production. The second industrial revolution used electric power to create mass production. The third used electronics and information technology to automate production, and it started the digital revolution that's been going on ever since the middle of the last century. Now, here's a little bit of a historical timeline on exactly how we did get here. In 1969, researchers for what was called DARPA sent the first data between computers in Los Angeles and Stanford University in Northern California. They were using ARPANET, a technology that would eventually evolve into the Internet. Now, by 1971, there were only 15 different nodes across the United States connected to ARPANET. In 1972, electronic mail was introduced. By 1973, the Transmission Control Protocol, or TCP, was created, and it established how information flowed between computers. From the mid-1970s onward, international connections to ARPANET were introduced. Now, fast forward to 1989, Sir Tim Berners-Lee invented the World Wide Web at the CERN Physics Laboratory in Switzerland. And the company, The World, became the first commercial internet service provider in the United States. In 1994, the very first search engine was launched, but at the time, there were only 2,738 websites. Soon after that, companies like Yahoo, Webcrawler, Lycos, Infoseek, AltaVista all popped up and were competing for popularity. But interestingly, most of those companies were affected by the bursting of the dot-com bubble, and only one of them is still around today. In 1996, Nokia released the first internet-enabled mobile phone. Now, the period between the mid to late 1990s was the time of the dot-com boom and what became known as the dot-com bubble. This was a period of extreme growth in the internet, and there was a lot of excessive speculation in internet-related companies. In 2000, that dot-com bubble popped. Some companies failed and completely shut down and went out of business. Others like Cisco, Amazon, and eBay survived, recovered, and really thrived. Now, following the dot-com crash, there was a period of reinvention. Web 2.0 emerged, and this really revamped the way that the internet was used. Now, Web 2.0 doesn't really speak to a technical specification, but it talks about the way that web pages are designed and used. A Web 2.0 website allows users to interact and collaborate with each other in a social media dialogue as creators of user-generated content in a virtual community. This is in contrast to the first generation of Web 1.0 era websites, where people were limited to the passive viewing of content. Now, fast forward to 2012, when 1 billion unique users appeared on Facebook. Today, there are billions of people connected by mobile devices, and they have unprecedented processing power and storage capacity, allowing unbelievable access to the knowledge that's available around the world. The possibilities are endless. There are disruptions in almost every industry in every country. Now, these possibilities are multiplied by emerging technology breakthroughs in fields like robotics, artificial intelligence, the Internet of Things, autonomous vehicles, 3D printing, nanotechnology, biotechnology, materials science, energy storage, and quantum computing. Already, artificial intelligence is all around us, from self-driving cars and drones to virtual assistants and new types of software. Thanks to technology, we're able to discover new drugs, and we see a merging of the digital and biological worlds. This fourth industrial revolution will not only change what we do, it'll change who we are. Our senses of privacy, ownership, our consumption patterns, the time we devote to work and play, how we develop our careers, cultivate our skills, or meet people and nurture relationships are all rapidly changing and evolving. The bottom line, however, is the same. Business leaders need to understand their changing environment, challenge the assumptions of their teams, and relentlessly and continuously innovate. Yes, the possibilities are endless, and they're only bound by our imagination, innovation, and transformation.
All right, class, we continue. Launched in 1989 at the European Particle Physics Laboratory, CERN, in Switzerland as a distributed collaborative hypermedia information system. It was designed by Tim Berners-Lee as a protocol for linking a multiplicity of documents located on computers anywhere within the Internet. This new Hypertext Transfer Protocol, HTTP, provided rules for a simple transaction between two computers on the Internet, consisting of establishing a connection, requesting that a document be sent, sending the document, and closing the connection. It also required a simple document format called Hypertext Markup Language, HTML, for presenting structured text mixed with inline images. An HTML document could contain hyperlinks or anchors that referred to other similar documents. With browser software, users could then click on designated areas of hot text in one document and jump to another, which itself might have more hot text pointing to yet other documents. Users could surf from document to document across the web, with HTML as the underlying buoyant framework. Berners-Lee is currently developing the next evolution, the semantic web, which provides a common framework that allows data to be shared and reused across application, enterprise, and community boundaries. Semantic web is an extension of the current web in which information is given well-defined meaning, enabling computers and people to work in better cooperation. The W3C semantic web activity, in collaboration with a large number of researchers and industrial partners, is tasked with defining standards and technologies that allow data on the web to be defined and linked in a way that it can be used for more effective discovery, automation, integration, and reuse across applications. The web will reach its full potential when it becomes an environment where data can be shared and processed by automated tools as well as by people. Okay class. Now we move to DHTML, stand for Dynamic Hypertext Markup Language, and XML stand for Extensible Markup Language. In previous slide we learned regarding HTML, where the HTML is an uncomplicated static web pages. But you will need other tools and programming know-how to deliver dynamic web pages that are built on the fly from text, graphics, animations, and information contained in databases or documents. JavaScript and programs written in Java may be inserted into HTML pages to perform special functions and tasks that go beyond the vanilla abilities of HTML, which means for mouse rollovers, window control, and custom animations. Cold Fusion and PHP are applications that run side by side with a web server like Apache. They scan an outgoing web page for special commands and directives, usually embedded in special tags. PHP originally stand for Personal Home Page, but it now stand for PHP, Hypertext Preprocessor. PHP is an application server. Working hand in hand with this application server, you will need a relation database management systems, RDBMS, such as Oracle, Sybase, or MySQL. These software will offer you to manage structured query language, SQL, database that may contain not only text, but also graphics and multimedia resources like sounds and clip videos. Compared to HTML, DHTML tools provide the power to perform real work and real tasks within the context of the World Wide Web. Furthermore, any animations such Flash or Director can be called from within HTML pages. All multimedia mini applications, often programmed by web developers, use a browser plugin to display the action and perform tasks such as playing a sound, showing a video, or calculating a date. As with Cold Fusion and PHP, these use underlying programming languages. With the introduction HTML5, browsers can play multimedia elements such as sound, animations, and video without requiring special plugins or software. On the other hand, XML actually goes beyond that HTML can do. It is the next evolutionary step in the development of the Internet for formatting and delivering web pages using styles. Unlike HTML, using XML you can create your own tags to describe exactly what the data means, and you can get that data from anywhere on the web. In addition, in development as a technique to deliver more pleasing web experiences, AJAX, which stand for Asynchronous JavaScript, and XML uses a combination of XML, Cascading Style Sheet, CSS, for marking up and styling information, and JavaScript to generate dynamic displays and allow user interaction within a web browser. For experience the web programming to feel as a web developer, I encourage you to go to the link given on the slide. Further instruction I will give during the lab session. Alright. Before we end our topic, this slide is a final subtopic in today's discussion. During the coming years, most multimedia experiences on the Internet will occur on the www, programmed within the constraints of HTML, then stretched by the enhanced capabilities provided by XML, Java, JavaScript, AJAX, and special plugins to enable browsers to exceed their limits. These tools are used to build Web 2.0 sites where there is collaboration and information sharing, such as seen in blogs, on wikis, and at social networking sites such as Facebook or Twitter. To design and make effective multimedia for this environment, developers need to understand not only how to create and edit the elements of multimedia, but also how to deliver it for HTML browsers and plugin or player vehicles. Well-crafted, professionally rendered sites on the web include text, images, audio, an animation presented in a user-friendly interface that balances the bandwidth deficit against user patience. Plugins, add-ons, and extensions add the power of multimedia to web browsers by allowing users to view and interact with new types of documents and images. Helper applications, or players, also provide multimedia power by displaying or running files downloaded from the Internet by your browser. But helpers are not seamlessly integrated into the operation of the browser itself. When an unrecognized embedded media type that cannot be displayed within your browser is called from an HTML document, most browser will automatically launch a helper application to view or run it. However, this helper typically starts up and runs separately from the browser. Many plugins are designed to perform special tasks not available without the plugin installed. As additional info, as a web developer or user, you must have an idea about WYSIWYG, means what you see is what you get. As a summary, Internet started with several clusters of computers attached to the network called LAN, and connected to another network at different location called MAN, and communicate with another network at different geography area called WAN, and the communication across the geography area by sending and receiving the data or files are called as Internet. User possible to get the Internet connection by subscribing to the ISP service. Every devices attached to the Internet such as server, personal computer, or smart devices will provided with a unique IP address. Every data, files, or web pages that stored in the server can be accessed by using an IP address or URL. The URL normally consists of the protocol scheme, subdomain, domain name, second-level domain, and top-level domain. Domain name server is to identify the server that stored the data. Other than HTTP as a protocol, we also have another protocol such FTP and SMTP. This protocol used to communicate between the HTML documents through the web browser. HTML is a static web page programming language. Hence, nowadays, we had DHTML as for a dynamic HTML web page programming. Other tools that support DHTML such as Ajax, ColdFusion, XML, and JavaScript. DHTML will allow the web browser to display the contents dynamically and display a multimedia elements efficiently in Web 2.0. Moreover, as a web developer or user you must concern with WYSIWYG during Internet surfing. Plugins on the web browser will help a user to display any multimedia contents such as audio or video effectively without any issue. Select a correct plugin to display a multimedia content on the web browser will influence the result of playing the multimedia contents. I think that's all for our discussion. Do have any question? When we finish today's topic, means we already covered all topic in this subject. I'm sure that everybody will be happy with current situation. But, you must remember that you still have a test 2 and group project that you need to be submitted. As a last word from me, please do the revision before test 2. Please submit the group project. Ask me if you have any problem to understand the topic. At the same time, I would like to take this opportunity to apologize my mistake along conducting this class. I just an ordinary person who can avoid from commit any mistake. So, please apologize me. I wish you all the best. Be a person that can benefit the community. Thank you for all your participation to my class along this semester. Do not forget to do the exit survey and SUFO. Thank you and see you again when I see you.